What is a limiting reactant? The reactant that is consumed first limits the reaction. Thus, it dictates the amount of products that can be formed. When the limiting reactant is all used up, the chemical reaction stops. What is an excess reactant? The reactant left over in excess after the reaction stops because of the limiting reactant got all used up. Why do we identify the limiting and excess reactant? Knowing the limiting reactants helps chemists calculate the amount of product to expect as well as how much of the excess reactants will be left after the reaction. Given the chemical equation C3H8 plus 5O2 yields to produce 3CO2 plus 4H2O, if we have 14.8 grams of propane and 34.4 grams of oxygen, determine the limiting reactant and excess reactant. But first, we must identify the given values, which is 14.8 grams of propane and 34.4 grams of oxygen. Since we have already identified the given, which is 14.8 grams of C3H8 and 34.4 grams of O2, and we have the given chemical equation of C3H8 plus 5O2 yields to produce 4H2O plus 3CO2. Here, we must follow the given equation in order to solve for the limiting and excess reactants, which is the given mass of the given element times the molar mass of the given element times the molar ratio times the molar mass of the element we are trying to find. Yes. So here, we will use 14.8 grams of C3H8 to determine the needed mass for O2. First, we must substitute 14.8 grams of C3H8 times the molar mass of the given element. Let's say in 1 mole of C3H8, there is 44.0 grams of C3H8. And then for the molar ratio, let's not forget in the chemical equation, we are given here 1 mole of C3H8, 5 moles of O2, yields to produce 4 moles of H2O plus 3 moles of CO2. So, we will write it as 5 moles of CO2. And then here in the chemical equation, again, we are given 1 mole of C3H8. We will write it as 1 mole of C3H8. And then, for our molar mass, we will write in 1 mole of O2, there is 32 grams of O2. Now, let's solve. Here, we are given for the final answer, we have 53.81 grams of O2. And then, for our second operation, we will use the given mass of O2 to determine the needed mass for C3H8, which is 34.4 grams of O2. So, same process. In 1 mole of O2, there is 32.0 grams of O2. And then, in the molar ratio, again, in the given chemical equation, it affects the way we solve it. So, we will write again 1 mole of C3H8 and then 5 moles of O2. And then for the molar mass, in 1 mole of C3H8, there is 44.0 grams of C3H8. And then, we will have, as our final answer is 9.46 grams of C3H8. So, okay. Here, we will now determine the limiting and excess reactants. Here in the given, we have 14.8 grams of C3H8 and 34.4 grams of O2. But in the solution we have, it is said here that we need 53.81 grams of O2. And then for C3H8, we need 9.46 grams of C3H8. Now, we subtract. For C3H8, we have 5.34 grams of C3H8. And then, for O2, we have 34.4 minus 53.8. We will have negative 19.41. So, how will you determine if it is the excess or limit reactant? In our solution, a while ago, it is said here that we need 53.81 grams of O2. However, in the given, we only have 34.4 grams of O2, which makes it the limiting reactant because we lack 19.41 grams of O2. And here, and for the excess, in the given, we have 14.8 grams of C3H8. However, in the solution, we only need 9.46 grams of C3H8, which makes C3H8 have an excess of 5.34. That's it. That's how easy it is. Thank you.